Hey guys, welcome to brainAttic. So today we have another very interesting and conceptual problem from the topic of differential equations. The question was most recently asked in JEE Advanced 2013. So if you do want to give it a try, you may pause the video now and give it a try. Otherwise, we can continue solving the problem. So we are given that let f be a function which has a domain over 1 by 2 to 1 both included, and the range is in all the real positive numbers. Now, the function f is also positive, non-constant, and a differentiable function. So we are given an equality with the differential function, that is f dash of x is less than 2fx, and also that f of 1 by 2 is equal to 1. Then we are asked to find the range over which the integral 1 by 2 to 1 f of x dx lies in. So we are given four options. Now, the concept in this problem is that whenever you see a linear differential equation in an inequality, the first step which you have to do is to identify whether the linear differential equation is increasing or decreasing. And how do we do that? We find the integrating factor. We find the integrating factor and then multiply the integrating factor to the inequality. Multiply the integrating factor to the inequality. So we are given we are given that f dash of x is less than 2f of x. So what I'm going to do is that I'll bring f dash of x minus 2f of x less than 0. Now this is of the form dy dx plus py less than 0. Now the integrating factor of this guy will obviously be e power integral over p dx. So the integrating factor of the problem which is given to us is e power minus 2 dx, and very easily we can integrate over the top and we have minus 2x. So when I multiply both the sides of the differential equation, multiplying if on both the sides of this differential equation inequality, we have f dash of x e power minus 2x minus 2 e power minus 2x f of x is less than 0. Now this, as you can see, is nothing but the differential of e power minus 2x f of x, and this you can write as 0. Now what do we understand over here? That therefore if I call this function as phi of x, so e power minus 2x fx, I'm calling it as phi. So phi of x is decreasing for x belongs to 1 by 2 to 1, which means that it achieves its maximum value when x is half, and then it keeps on decreasing after that. So this is x equal to half, and this just a diagram I'm drawing for explanation, and somewhere 1 is over here. So any value for when x is greater than half, then your phi of x will obviously be less than phi of 1 by 2, because when x is greater than 2, you're somewhere falling in this area. So obviously your phi of x is always less than phi of 1 by 2. So this is nothing but e power minus 2x fx less than, now I apply the value over there, e power minus 1 f of 1 by 2, and f of 1 by 2 is nothing but equal to 1, since we know this. Then I can rewrite this as e power minus 2x f of x is less than e power minus 1. Now I'll just rearrange the terms, and this is what I have, e power 2x minus 1. Now I also know that f of x is a positive function. From the question itself, it was mentioned that f of x is a positive function. So my inequality for f of x right now stands like this. Now the question asks me to find the integral over 1 by 2 to 1 f of x dx. So the problem is now very straightforward from there here on, minus 1 dx. So solving this integral, we have 1 by 2 to 1 f of x dx less than e power minus 2x minus 1 by 2 over the range 1 by 2 to 1. We apply the value and we find that this integral falls in e power 2, sorry, e power minus 1 by 2. So my range is e power minus 1 by 2, 0 to e power minus 1 by 2, both excluded. So my option D is correct. So if you do like the video, hit the like button, subscribe to our channel for more content like this. Thank you so much for watching.